I'm going to show you problem 1, and what we're looking at here is that we have a function of x, and it's the absolute value of x plus 2. And it says, note that this has the form f of x, so a function of x, plus 2. And so we want to think about that in terms of a function plus 2 and how that ends up looking on the graph. So let's take a look. First thing we want to do is identify the parent. And those are going to be those shapes that you found at the beginning of the 2.5 pre-class worksheet. So you might have had an absolute value shape, which was a nice V shape that was symmetric, and in the form of a V, it doesn't have soft or rounded sides. They're very much straight lines. And that's what we're looking at here, and I can see it here that x, the absolute value of x right there. So whatever is being done to the x is what I'm concerned with here. So what the parent here is going to be the absolute value of x. And what I know about the absolute value of x is that it's symmetric, so whatever I find on one side, it should match on the other side. So I just want to find 3 points that I think will be helpful for graphing. So -1, 0, and 1 should help me. If I plug -1 into the absolute value, I get a +1. 0 in, I get 0, and I plug 1 in. Remember, it'll stay positive, so I'll have a +1. And when I go to graph, there's my 0, 0 right there at the origin. -1, 1, and 1, +1 as well. Remember, straight sides, so those are going to go up if I can make my lines go through my dots here. And so it should look something like that, maybe a little bit straighter if you're not using a weird input device like I am. And then I want to do some changes to that graph, because what I'm really interested in is not so much the absolute value, but what does it look like when it's the absolute value plus 2. So that's where I'm going to put my f of x is actually the absolute value of x plus 2. So if I use those same x's, which I want you to do, and I want to switch colors here real quick. So I'm going to use the same x's, -1, 0, and 1. And I can plug them in, or I can think about, well, I already found the absolute value piece. I just need to add 2 to each of those y's. Or I can think, okay, here's my -1, put it in for the absolute value of x. That'll give me a +1. Add a 2, and that's going to give me a +3. Plug in 0 for the x, that's going to give me up here a 0, and then plus 2, that'll give me a 2, a +2. Plug in the 1 for the absolute value, still a 1, and then add 2 to that, and I'll get a 3 for this one. Now let's plot those points. So I'm here at 0, 1, 2. For the y direction, and then -1, 3, and +1, 3. So I can see my V taking shape again. And remember, I only need a couple of points because I know that the shape should be a V. I know the sides aren't going to be rounded, so I don't need to worry about finding that exact rounded curve for a parabola. It's not a parabola. Okay, so what I want to notice here is it has the form f of x plus 2. So when I look at that graph, I can see that the shape of the graph was a V, and it was centered at the origin at 0, 0, and then the effect of putting the absolute value of x, which was at 0, 0, with a plus 2 on the end outside of the function, is that it shifted my whole graph up by 2 units. And you can see that the shape is the exact same with the blue graph, and then bump, bump up 2, and the red graph is the result for the f of x plus 2 form. Okay, you should work these pages in between and try these different transformations, is what we call them, when you're taking a graph and transforming it or sliding it, flipping it, all the different activities we can do with a graph.